What if we had a tool that would allow us to basically do this? So take numerous vectors, add them together, and then find out what the resultant vector is. So that's what I want to be able to show you in this video. Let's get ourselves started. Welcome to the video. I'm going to go over Desmos and the powerful tool that they have added with regards to geometry. And for anybody who's working on finding resultant vectors, this is an amazing tool to be able to visualize for yourself how these vectors work, how to calculate magnitudes, angles, pretty much anything that you want to be able to do so that you don't necessarily have to utilize, your hand-drawn tools. So let's take a look here. So I'm going to work on, let's imagine that we have 3 vectors. All right, so these are the 3 vectors that we have. And someone comes along and says, okay, well, what's the resultant vector? So what is basically the addition of the 3 vectors that you would have if this was given? Now, notice this is given on purpose, where the first vector right here, so that's in geometric form, so it's 125 at 60 degrees. Now, these vectors, they might have units if you're working with forces, if you're working with displacements, velocities, so they might have that. Now I'm omitting that, I'm just treating these as regular vectors, okay? So the V just stands for vector, not for velocity in this case. So this one is in geometric form, notice this one is in Cartesian form, and this one is also in geometric form. And of course we can say, all right, so well, the resultant vector is just simply the addition of the 3 vectors. And you can find that by, for instance, breaking it down into the x and y components for each vector, and then adding up the components, right? So the x component and then the resultant y component, and then bringing it all back in to find your result. That is fine. But here I want to be able to show you how you can do this in a very powerful way through an online free tool, which is Desmos. Okay, so the first thing that we're going to do is we're going to load up Desmos. Okay, so you can go to desmos.com, and once you click on that, you'll come to this welcome page. Now they might update this page depending on when you watch the video. And now notice, so they give you kind of different choices. So graphing calculator, but now on the right hand side, they have explore geometry, and they have this geometry tool. So I'm going to hit on this open geometry, and it's going to load up for me, okay, this page. Now this on the bottom left hand corner, so the keyboard might be hidden, you can always bring it back up. Okay, so we're going to be using this. Now our goal is going to be to find the resultant vector, and I'll show you how you can do a lot of neat things here when you're working with this tool. So the first thing that I would want you to do, just to make it more visual for yourself, so on the right hand side you see this wrench, which is the settings. Okay, so I'm going to just click on that, and the first thing is just make sure, so there's radians or degrees. This is going to be for the angles that you use for your vectors. So I want it in degrees, so I'm going to click on degrees. The next thing is I want to be able to see a grid. So this is really neat, because when I click on grid, and notice it also shows you a minor grid, this gives me a grid so that I can start drawing things out. All right, so that's what we would have. And then I also want an axis. Okay, so I want to be able to label and then actually see an axis, so that when I'm putting in my vectors, okay, I'm going to be able to do this directly. All right, so that is that. Now you can zoom in and zoom out using plus or minus, or if you're using a tablet, you can pinch, okay, and pinch out. Okay, so you can zoom this whole thing in. So we're going to be zooming out because the numbers, okay, that we have are a little bit bigger. Okay, so within there, I believe that the vectors that we had, are kind of in the 100 or around 100 range. So I'm going to kind of zoom out in here so that I can fit them in here. Now at the top corner, okay, so at the top you have basically a choice. Now you have, a pointer that you can do. You can notice, I'm going to just click, you can create points. Okay, you can create, so I'm going to hit here, you can create a line segment, a line, ray, notice a vector. So you can actually draw a vector directly. We can also do circles, okay, and arcs, and we can also do angles. So this is really neat. So between 3 and any points we want, we can create angles within here. So now we can use these and start to input, okay, what we want. Or on the left-hand side, we can actually write out the vectors directly. So it tells us, okay, what we would want. And I want to just be able to show you. I'm going to do the same exact thing in both ways. So for instance, I'm going to take, okay, the vector that I have. I'm going to now kind of change this back in here. I'm going to shift this out of the way so my Desmos is a little bit bigger. Okay, I'm going to zoom in, okay, on those vectors. So hopefully you can see them on the screen as well. And I'm going to work through them. Now I'm going to first, okay, so pick the vector, and let's make it very simple because we have a Cartesian, okay, vector, which is negative 100, okay, comma 150. So the x component is negative 100, and then the y component is up 150. So I just want to show you how to do that. So the first thing I'm going to do is I'm going to actually input this in. So I'm going to call this actually v2. So that's going to be my second vector. I'm going to put equals, okay? So I'm just defining it directly. Now I wish I could write it out the way that it is written right there for us, but I do have to call a tool. I have to say, okay, I want a vector. So you can actually type out vector. Now here, it is hoping for the vector, the starting point, right? So basically, okay, your start and then your end point of the vector. Now my starting point, so within here, as I first draw them, my starting point is going to be the origin. So I'm going to put a point, okay, which is going to be the origin. So 0, 0. So that's how you can put it in regular round brackets. That's my starting point of the vector. I'm going to put a comma, and now I want my ending point. My ending point is always, okay, the Cartesian representation. So in here, it's going to be minus 100, comma 150, okay, and look at that. So it's pretty wicked, okay, and if you hold down on the left-hand side, okay, the actual squiggly line where it's showing red, you can change the colors, okay, to whatever it is that you like. So I'll still keep it red, okay, for this vector. So that is one way of actually being able to create this vector that you have in here, all right? Now, what's very neat, that what you can do is, once you created the vector, you don't have to keep rewriting it, you can just write v, okay, and I'll put a little subscript 2 in there. And for this, if I put a dot, I can say start, and notice it's going to put the starting point. So it has labeled in here, so as you can see there, it put a blue dot right there, and I can put a little label, I can check that off, and it actually will put the point for me, so 0, 0. I can also put the v, okay, 2, so again, dot, and I'll put end, and it will put an ending point there for me. Now, if I want it in the same colors, I can grab it in. So maybe, you know, I want to keep them, these points as blue. So there you have it. That's what I'll have there. And that's what I would have. And that actually tells me the starting and ending point on my grid. So that's really, really neat, right? Okay, so that you can actually do that. Now, this is just inputted it in. Now, what else is really neat in here is that you can actually check, okay, so the length, the magnitude of the vector, right? So you can actually figure out what that length is. So here, so notice if I put v and I put 2, I can put dot, okay? So this basically calls what do you want, and you can put length. And if you put length, notice it displays and tells you exactly how long that vector is. That's the magnitude. And now the other very neat component, I'm going to shift this out of the way, is once we have this, so this is, I'm just working with one vector just to be able to show you all the neat things that are happening here. I can actually now use the tool and figure out what the angle is in between. Let's say you wanted to do that. Now, of course, you may know how to do that using sine and cos. Okay, so it's not a very big deal. It's not very hard because now we know what the actual length of the vector is, so you can find out what those angles are. Or you can use, you know, your tan, okay, so tangent function, okay, to be able to find all that out. But what else you can do is, you can click on the actual display here and you can find out the angle. And now for this angle, we want to start from the x-axis. Now you can put any, okay, starting point that you want as long as it's on the x-axis. I'll put it on 100 there, so that's a point, that's my starting point. Then I will point it at the vector, okay, at the 0, 0 point, and then I will point it at the end, okay, right there. And notice it is giving me the exact angle, which is really neat. Now, of course, I can swing this, okay, out anywhere I wanted to, but that's what I would have. And that's very neat, and it stays there for you, and you can actually see that angle, and it displays it. So in the geometric side. Now, if you wanted the opposite angle, you can do that, right? So, you can certainly try to do that as well. Now, if you want to get rid of this, so I don't want to necessarily see it, you can click on one of the points, and notice it gives you selection. You can hide it or you can delete it. Okay, so within here, so if I put hide, okay, it will hide that point, it will show that point. If I put delete, it will delete the entire angle that I've created. So that's really neat to be able to see that. Now, let's take a look at some of the other vectors. So this is, one vector that I have, and I'm going to remove all of this entirely. So I don't want to necessarily see any of these, so I'll just delete it right there, and I'll just leave the vector on its own. All right. Now, if you click on the left-hand side on that, okay, so I'm just clicking it back and on, notice it shows and it displays on the left-hand side. I'm going to just delete it for the moment, right? So I don't see it, and I want to show you how else, okay, so what is another way of creating this instead of typing it in? And what's really neat is I can put in, so notice where it shows me that line segment. I can click on that and I can say, I want to create a vector. And now you can put in, so you can actually input. So with your mouse, or I'm using my pencil in here, so I have my starting point, so I'll just click on my starting point. And now I want it at -100, 150, right? So I can go all the way to that, and look at that. It creates that vector for me. And that's really, really neat. Now, in order to be able to see it, so on the left-hand side, so you know how you have a display where it just kind of actually shows you how it looks like. So you can actually click on, and there's a plus there that you see, and right beside the plus, okay, there is almost like a geometry tool. So notice I'm just clicking it back and on. And now here, this tells me what is actually displayed on the screen. So in the purple, so there's 2 actual points that are displayed. Now I can actually take that point and drag it. So with your mouse or with your pencil, you can take that point and drag it onto the display. So I can take this in, notice it's dragging on, and look how wicked that is, that it just actually puts the point back in there. Okay, so this is exactly what I wanted to see. Now, if you don't want to see that point, or you want to remove it, you can get rid of it entirely, and it will remove, okay, whatever was attached to it. So again, this is, the hiding, okay, right there for us. Let's draw that vector again, and I want to be able to show you what else it has. So my starting point, my ending point right there. Notice it now shows up for me. Now I'm actually going to drag in, and I'll take the vector. So the vector is the actual blue in here. And I'm going to drag it back in here. It's not going to have the same name, right? But it shows me V3. That's what it called it, V3. You can change the name if you want by clicking in and then typing in whatever you want to call that vector. And notice that it creates the vector from 2 points, but those 2 points are the points which are displayed. So it just literally just puts a point. But if you want to know what those points are, you can take those points, drag it back in here. So that's one of the points. Drag it back in here, and now it will actually label. So notice there's point 1 and point 2, and you have that displayed. So that's really, really neat, right? So now we have 2 ways of showing a vector. You can input it directly. I'm going to now highlight this. Notice these 2 vectors are now on top of each other. I can remove the blue one, okay, hide it away. I can also hide away if I click on the points so that you don't see them, or I can click on them and then they'll show up again, and then the vector that I have. So I'm going to just remove those, okay, from the viewpoint. So there's 2 ways of creating these vectors, okay, and that's really, really neat to be able to do that. Let me remove, I'm just going to leave 1 copy of the vector, which I called V2, and that is exactly what we want. So what else would we want to be able to do here as we're working through? So let's kind of go back into these vectors, right? So these were the vectors that I had. How am I going to actually take in this vector and input V1, which is 125 at 60 degrees? And here is what is really, really neat to be able to do that. Sure, You can do the calculations on your own, right? But, okay, I'm going to go in and I'm going to create the vector components in here. So in order to do this vector, now 125 at 60. So let me input my vector number 1, and I just want to show you, how really neat this is. So my vector, let's say I wanted to start from 0, 0. Okay, so this is my vector number 1. Now I need my second point. And now it's 60 degrees, correct? Now 60 degrees, well, how am I going to input that in? So I need the x value and the y value. But hold on a second, we know how to do that. This is 125, and notice what you can do in here. You can input 125 times, and this, you can put up the keyboard in here, and you can use your times, divisions, and so on. And it also has various functions like sines, cosines, etc. that we have. Or you can type them in. I'm gonna just directly type it in. So this is cos, okay? And it is cos of 60, right? This is my x value. My y value is 125 times sine of 60. And then I will just close this in here, and it will see, and you can see there, it draws the vector directly. And this is exactly what we have. And now if you want to double check for yourself, right? So what I'm going to do here, so within here, so you can say v, okay, and subscript, so 1 dot length, and notice it's 125, which is exactly that. Now, what about the angle of this one? So if you wanted to know the angle, you can hit on this and go on the angle. And again, I'm going to just start from the angle 1, 2, and then hit on the end. Notice it shows me, indeed, it is 60. So I inputted it correctly. And that's pretty neat, right? To be able to do that as I'm going through. So I'm going to delete this angle at the moment. Now I have two vectors. I have v1, okay, and v2 in here. So those are the vectors that I have. Now let's try to continue on, and let's put the third vector in here. Now the length, okay, so I'm going to just remove that in. So I have vector 1 and vector 2 as I'm going through. Now my third vector that I have, so for this one, so again, let's bring this back up. So my third vector is 80, and that would have been, so this is going to be v3 is equal to vector, again, so starting from the origin, and now this is going to be 80 and times cos, okay, of 225, and this is going to be 80 times sine of 225, and notice it actually shows me the exact vector again. So now I have all the three vectors, and they're visually shown for me. And now here is the most amazing thing, because sure, you can break them down into components, okay, and try to find these out. But in here on the left hand side, if you say, so you can call it whatever you like, the resultant vector. I'm going to just put v subscript r, okay, so I'll put a little subscript r in there, and it equals to, and check this out, v1, and you can literally add the vectors, v2 plus v2, like you would be adding numbers, and v3, and it actually will show you what the resultant vector is. And that is super cool, right? And if you want to know what the actual length of that vector is, so you can put vr, and here you can put dot, and you can put length, and it will tell you what the magnitude is. So that's the magnitude. Now, another way that you can show the magnitude is if you put straight brackets. So these are called absolute values, and you can put the vector that you like, and it will do exactly the same thing with these straight brackets. Straight brackets actually mean the absolute, okay, or the magnitude, in this case, of the vector. So either or will work. Now, if you wanted to know what the angle of that is, no problem. You can go back in here and you can say, I want an angle, and my angle is between this point. So again, starting from the x, depending where you want that angle. Okay, then you go to the origin, and then you go to the tip of your actual resultant vector. And it says, okay, it's 115. And now this one I'll just leave there just so that you can see that, okay, in terms of the resultant vector that we have. So that is really, really neat to be able to see. Now, let's imagine, because the addition of these vectors that you have, you know, you maybe have once drawn them out, right? From tip to tail, and as you're going through, you eventually will get a resultant vector. All right, so this is now kind of a recap and a deja vu. So basically, we had 3 vectors. All right, so we had vector 1, vector 2, vector 3. Okay, so I've plotted them out. Okay, so they're starting at the origin. They're plotting out. It's almost like if you were doing, okay, kind of vectors in various directions. And then what we want to be able to do is find the resultant vector from those 3. So we want to add them together. And once we have that resultant vector, we can find out what the magnitude of it is. We can certainly find out what the x and y components are, and the angle itself. All right, so let's do kind of like a final recap here, okay, in order to show you, you know, how we came up with all of this. So I'm going to kind of just on the left hand side, so please pay attention. Okay, there, I'm gonna remove all of these various items. Okay, so from there, and all I'm gonna leave is now the 3 vectors. So let's assume that you put the vectors on together. So the first thing is, okay, let's find the resultant vector. So you can call it whatever you want. All right, so you can call it V, okay, whatever it is that you like. I like to put a little subscript, okay, that I have. And now this particular vector, I'm going to be adding up all the vectors together. So V1 plus V2 plus V3, and there's my resultant vector. Okay, so I'm gonna hit basically enter, and there it is. Now, what do we want out of this vector? So you can find out numerous information. Let's say, okay, you wanted to find out what the x and the y values are. So you can, again, you can enter the vector, and then you're gonna put a dot, all right? And then you can put start, and that particular start is going to tell you exactly, okay, where that vector starts, okay? So you can label it, so that's 0, 0. You can say V, okay, you can say R. Now you wanna see what the vector actually is, so you wanna find the endpoint, so there it is. You can click label, and it's gonna give you those values right there, so you can do that all at once, okay? So I'm gonna just adjust it just so that you can see these particular points, okay, and then label them. Let's make it a little bit bigger there, just so that it really pops out at you, okay? So there you go, you can have that. You can round to whatever it is that you please. Okay, so those are the 2 items, okay, that would give us the Cartesian representation of the vector. If you're interested in now finding out what the geometric representation is, you can, again, you can put V, K, R, you can put dot, and you can put length, okay? And that's going to give you exactly what the length of that vector is. Another way to do that is you simply put the brackets. This is from your keyboard. You can put in this bracket, and then you can put the vector, whatever name that you gave it, close the bracket. It will give you exactly the same thing, which is the magnitude from start to finish. If you want the angle, so in here, so for the angle, so what I like to do is I'm gonna go and hit right on top on the tools, okay? So hit the angle itself, and now I'm gonna construct the angle that I want. So the starting point, if you want it with respect to the x-axis, you put a point on the x-axis. So I put it at 100, okay, 0. Then I go to basically where the vector begins. So that's the start of the vector. So that's gonna be at 0, 0. So I click on that. And then I click on, okay, with your mouse, okay, or your pencil, you click on the end of the vector that you're interested in. So here I'm going to be clicking right on the end button right there. And that's going to give me what those actually are, all right? So it's 115, okay, degrees, okay? So more or less, that's what I would have. Now, on the left-hand side, so if you want it, I'm gonna go back, I'm gonna drag these things in here. So notice I have point P1, P2, okay, in there. They're showing me the starts, the endings, okay, so I can drag on. I'm gonna drag on this, okay, right there as well, just so that you can see those particular points in there. So I have those points, okay, so that is point and this starting point that I had in there. So notice that it doesn't look like it's at 0, so I'm gonna just adjust it. All right, so this Okay, so I want it at 100. Okay, that's the starting point, and 0. So that's what I would want. And I guess that's the reason why it wasn't 115 as we originally had it. Okay, so there you have it. Okay, you can always adjust the points, drag them back in, okay, and then put them in. So notice that my other points are at the start and at the end. Okay, so that's exactly what I wanted for us to be able to see. All right, so now if you want that angle, you can also drag the angle in here. Okay, you can put this angle, I'm gonna put it all the way. Okay, maybe I won't put it at the bottom just so that you can see it. Okay, and then you can label the angle accordingly right there. Now, if you wanted, okay, so if you wanted to find this angle instead of using the tool, you can indeed, okay, input this in here so you can find exactly the same thing. So I'm gonna kind of remove this out in here. So this is what I'm gonna do. So if you wanted to label that angle, let's call it angle, okay, of the resultant vector. So I'll put it R, that is equal to, so again, you can put angle, okay, instead of dragging it out, and now you can put the starting point. So it needs a starting point, so somewhere on the x-axis, so I'll put this point right there. Now it needs the second point, which is going to be now the vector itself, so this particular, okay, starting point, so I'm going to put R start, that's at the start, and then at the end, so this is V, okay, R, and this is going to be the end of the vector. Okay, and that's what I would have right there, and then you can label it in there. Notice it label it back. Now, so how you do those angles is up to you. So now you have seen both, okay, in terms of drawing it and actually inputting it in here. So now you can label it. So you can have the resultant vector, both the Cartesian coordinates now, and you can have the magnitude and the angle. This is amazing tool that you have within Desmos. If you want to explore further, you can look up, so on the top right hand there's a little question mark there, okay, right here. So you can put feedback in there for them, but there's a geometry user guide, and if you click on this guide, it actually goes in pretty deep on everything that you have, okay, within here on the geometry side. So if you really want to push yourself, not just on vectors and other stuff, what's available there to you, you can do that. So it's pretty amazing tool. All right, so there you have it. Thanks for watching. Hope that you found this useful. Happy studying and happy learning about vectors. Bye, everybody.